Okay, in this video, we're going to throw all of our conic sections together, and we're going to talk about identifying what type of conic section it is. We're also going to talk about the general form, and here's your general form for a conic section. You have ax squared plus cy squared plus dx plus ey plus f is equal to 0. And you might be asking, well, where's the b term? Later on, you'll find out that you could put a bxy term in there, and that would actually rotate your conic section. But for now, we're just going to stick with this general form right here. Now, this is pretty neat. You can actually identify what type of conic section you have based on the values just by simply looking at them. And here's all you have to do. First, look and see, just all you have to do is look at your a and c terms. Which variables are squared? If just one is squared, either just have an x squared or just the y squared, and the other one is just plain x and plain y, if just one is squared, it's a parabola. And that should make sense from what we've done the past few lessons. If both are squared, go to the next step or next test. Look at those same coefficients. If they are exactly the same, then you have a circle. If they are different, A and C are different, just the coefficients. If A and C are different, but they have the same sign, it is an ellipse. Because remember the plus sign, if both are pluses, or if both are negatives, that negative could be factored out. If they have opposite signs, then it would be a hyperbola. So let's use that test here. And again, all you have to do is look at your x squared and y squared term. It's not a parabola because both of them are being squared. If they're the same, it's a circle. If they're different but have the same sign, they're both positive, so therefore this would be an ellipse without having to do any more work. The next one, notice that only the x is being squared. There's no y squared, so right off the bat, we know that's a parabola. On the next one, here's your x squared and y squared. Notice they are both being squared. It's not a parabola. However, they are the exact same coefficient, which is 1. This is a circle without going any further. And here your x squared and y squared have different signs. It's a negative and a positive, so therefore this would be a hyperbola. Okay, the next section says determine the type of conic, then write the equation in standard form, and then we're going to graph it. Okay, let's first identify what type it is. Since only the x is being squared, this is going to be a parabola. And reminder that since it's x squared, your standard form is going to be y equals 1 over 4p times x minus h squared plus k. Now to get it in that form, all of these we're going to complete the square. So what we're going to do, we're going to move everything over to the other side that is not x stuff, x squared minus 8x. We're going to take our y, move it over here. We're going to take our 14 and also move it over here. We're going to complete the square. Let me change colors. So take half of this term, which is -4, multiply it times itself, and add that to both sides. And we're nearly finished already. Once you finish completing the square, you simply factor. This will factor into a perfect square, and it always factors into half of this term. So equals -y plus 2. Now, I don't like that -y term, so what I can do is I can take this -y and I can just move it to this side and take this whole term, which is a plus, and move it to this side. And it's going to change my -y to a positive y over here. It's going to change my positive x plus 4 squared to a negative positive x minus 4 squared to a negative x minus 4 squared. And then that plus 2 just stays put. And there is your new parabola. Okay, let's first identify our vertex, which can be located right here. Our vertex is shifted to the right 4, and it's going to be moved up 2. So our vertex is now located at 1, 2, 3, 4, 2. There's your vertex. Our p-value, which we will find it, is located right here. So we're going to 1 over 4p is equal to -1. So that means that 1 is equal to, let's move this up by multiplying -4p, divide down by the -4, and we get that p is -1/4. So therefore, since it's a negative value, that means that our focus is going to be below it, our directrix is going to be above it, And you can spend more time. You could find some x-intercepts and all that stuff, which let's go ahead and do that just to remind you. Next up, we'll find some x-intercepts. The way we find x-intercepts is by plugging in 0 for y. So we have 0 equals -1 times x minus 4 squared plus 2. Move your 2 over by subtracting. -2 equals -1 times x minus 4 squared. Move the -1 over by dividing. That now gives you a 2. To get rid of the square, we're going to do plus and minus the square root of that 2 is equal to x minus 4. Move the -4 by adding. So there's your two vertices, or excuse me, there's your two x-intercepts. And that would be, let's see, 4 plus 1.4, which is about the square root of 2. That's going to be 5.4, or 4 minus 1.4 would be about 3, or 2.6. So at 5.4, 1, 2, 3, 4, 5.4, somewhere right in there, and 2.6, 1, 2.6, somewhere right in there. And then we'll just sketch out that parabola. Nothing exact, but it'll look something like that. Number 6. Again, first step, let's identify it's an x squared and y squared, so they're both being squared. They're got to be careful. They're different signs. It's a positive one and a negative one. This is going to be a hyperbola. So to get it in the right form, again, we group our x stuff together. X squared minus 4x, skip a space. Negative y squared minus 6y, skip a space. Let's move the 9 over to the other side is equal to 9. Since it is a hyperbola, let's factor this negative out of the second group. And I'm going to group these together in some parentheses just to show you. So we have x squared minus 4x, and then this minus, I'm going to factor out of the second one. And again, reminder, this minus tells us it's as a hyperbola. It's x stuff minus the y stuff. So when I factor that negative out, I'll have a y squared plus 6y inside those parentheses equals 9. Now let's complete the square. Take half of this, multiply it times itself, we're going to add 4. Make sure you add it to both sides. Take half of this, multiply it by itself, add 9, but be careful. You have a negative in front of those parentheses, so we actually added a -9 to that side, so let's add a -9 to the other side. Let's factor one set of parentheses because we know it's a perfect square. Adds, multiplies would be a -2 in itself. Minus, second set of parentheses, should be a perfect square. Adds, multiplies will always be half of this term, which is y plus 3 squared, equals, these actually cancel and leaves you with 4. So we're nearly there. The only thing is, with a hyperbola, this is equal to 1. So we're going to go through and we're going to divide every term by 4 in order to get a 1 here. And we get now, we don't have to reduce anything else except for this over here. 4 divided by 4 is 1. Here is your hyperbola. Reminder that this is going to be a horizontal hyperbola because the x stuff is first. The center of this hyperbola got shifted right 2 and down 3. So 2, -3 will be the center. Let's go ahead and graph that. Our a value for this hyperbola here is a squared. And here is b squared. So therefore our a value will be 2 and our b value will be 2. So let's go ahead and plot those. And the way we're going to do that, since this is a horizontal hyperbola, our vertices will be to the right and to the left of our center. Our co-vertices will be above and below our center. And again, with a hyperbola, that's going to create a box. And the way that we're going to use that box is we're going to connect the corners, and those corners will give us some asymptote lines that we can actually use to graph this hyperbola. And there are those asymptote lines that connect the corners. Now, you given A and B, if you were to look for C, if you wanted to find C, you could use A squared plus B squared is equal to C squared and plug all that in, and that would give you the distance to your foci. But to graph this, since it's horizontal, now what we can actually do is just go from our vertices, which are here, and just follow those asymptote lines. So it's going to come up and down and look something like that. And then to the left, it would look something like this. And there is your hyperbola. Okay, next up, number 7. First off, notice that your x and y squared have the same number in front of it, 1, so therefore this would be a circle since they're the same. We're going to start out the same way. Let's move all our x stuff together. Plus y squared, put all your y stuff together. And the constant, we're going to move to the other side. We're going to complete the square by taking half of this, multiplying it times itself. Make sure we add that to both sides. Take half of this, multiply it by itself, add that to both sides. We are now going to factor, and we didn't have to, hang on, let me make those parentheses smaller. We didn't have to factor the negative out on this one in the middle because it is a circle, so you're not going to have to worry with that. So you're going to have something like this now. The x stuff, when you factor it, gives you x, x times x gives you the x squared. Adds, multiplies would be a positive 5 times itself. With the y stuff here, when we factor it, y times itself gives you the y squared. What adds, multiplies would be a positive 1 and a positive 1. And on the other side, you have negative 17 and 25 is 8 plus 1 is 9. So there is your circle. And that is in your basic form. The center of your circle got moved left 5 and down 1, so negative 5, negative 1. So let's go ahead and plot that center. Now the radius of your circle, this would be the radius squared. If you remember the basic form of a circle is x minus h squared plus y minus k squared equals r squared. So that's your r squared. The radius in this case would be 3, so we're going to go up 1, 2, 3, right 1, 2, 3, down 3, and left 3, and we're going to now connect our dots. And there's your circle. Next problem. First, determine what it is. Look at your x squared and y squared term. Both of them are positive. They're the same sign, but they're different numbers. So therefore, this would be an ellipse. Start out the same way. Group your x squared stuff together. So we have 4x squared. Well, there's no other x squared. Group your y squared stuff together. You have y squared plus 2y. And I'm going to go ahead and put those in parentheses just to show you that I grouped them. Move the 35 over to the other side. Now let's complete the square. We're going to take half of this and square it, multiply it by itself. So we're going to add 1 to both sides. Nothing's outside of parentheses, so we're good there. So I have a 4x squared plus, go ahead and factor this. Factors into y times itself gives you y squared. What adds, multiplies would be a positive 1 times a positive 1. So that is a perfect square equals 36. Now the last step, this over here has to equal 1. So we're going to go through and we're going to divide every term by that 36 in order to get equals 1 over there. So now the 4 over 36 reduces, gives me x squared over 9, plus the y plus 1 squared. Nothing's out in front of that that's going to reduce with the 36 is equal to 1. And there is the basic form of your ellipse. Now, when you're dealing with an ellipse, reminder that the largest number on the bottom is your A. The smaller number is the B value. So therefore, here my A value would be 6 and my B value would be 3. And we could use A squared minus B squared to find our C value. A squared minus B squared would equal C squared. But this is all we'll need. Our center, we can look here and here to find our center. It got moved left or right 0, but it did get moved down 1. So the center is going to be located at 0, negative 1. Now here's how we use our A and B values. Since the 6 or the 36 is under the Y value, that means that my 6 is going to go up and down. Okay, we're going to go up 6, 1, 2, 3, 4, 5, 6 up, and 1, 2, 3, 4, 5, 6 down. Since our 9 is under the X value, that means that the square root of 9, which is 3, that means we're going to go right 3, and we're going to go left 1, 2, 3. And that's it. That's your ellipse. Let's connect our dots. And there you see a picture of what your ellipse would look like. Number 11. Let me erase that. Or excuse me, number 9. Notice that only the y is being squared, so this is going to be a parabola. Let's isolate, let's group all of our y stuff together. Everything else moves to the other side. So y squared plus 8y equals, move your 4x over and move your 4 over. Reason we're doing that was we're going to complete our square here. Take half of it, multiply it times itself, gives you 16. Now that you've completed the square, let's factor it. Y times itself gives you y squared. Adds, multiplies would be a positive 4 times itself equals 4x minus 4. Now next up, we are going to, you can go ahead and move the plus 4 back over. Now this one's a little bit trickier. You have y plus 4 squared plus 4 is equal to 4x. Now what we got to do is we've got to go through to get rid of this 4 here. We've got to divide both terms. You've got two terms over here. We're going to have to divide them both by 4. Okay, and that's going to get rid of it. Now we have x is by itself equals. There's a 1 out in front here, so we're going to rewrite this thing like this. We're going to rewrite it as 1/4 just to make it look like the form that we're used to seeing. Y plus 4 squared plus 4 divided by 4 is 1. There's our basic form. Since it's an x equals parabola, that means it's going to either go right or left. It's going to be a horizontal parabola. Our 1/4p right here is equal to 1/4. So therefore, that's kind of simple. Our p-value's got to be 1. Since it's a positive, it doesn't mean, that means it does go, it's going to cup to the right. To get our vertex, we're going to look here and here. The plus 1 is going to move our vertex, because it's the x value now. The plus 1 is going to move our vertex to the right 1. The plus 4, since it's inside with the y, is going to move our vertex down 4. So our vertex is now located at 1, -4. Let's go ahead and graph that. And there that is. Since our p-value is positive, our focus is going to be to the right and our directrix is going to be to the left. And instead of doing an exact graph, let's just go ahead. Our parabola will bend around that vertex and it will, or focus, and will look something like that. Now you could, again, you could plug in some points to get a more exact graph, but that's a pretty close approximation of what our graph would look like. Number 10. We have another circle because x squared and y squared has the same coefficient. So now let's go ahead and see what the circle looks like. Let's group our x stuff together. X squared plus 12x, leave a space. Group your y stuff together, leave a space. Move the 21 to the other side. Let's complete each square. Take half of it, multiply it times itself. So we're going to add 36 to both sides. Take half of it, multiply it by itself. Let's add another 1 to both sides. Now we're going to factor one set of parentheses. X times itself gives you x squared. Adds, multiplied is always half of this term. It'll be plus 6. Same thing with the y. Y times itself. Adds, multiplies is always half of this term, which is -1, equals, on the other side, you have 16. So therefore, our center of this circle got moved left 6, and it got moved up 1. So -6, 1 will be the center. So let's go ahead and plot it. And here is our radius squared. So therefore, that means our radius would have to be 4. Let's go ahead, up 4, down 4, left 4, right 4. And there those points are. Now let's connect our dots, and that would be our circle. And there you go. Next problem, number 11. Notice that your x squared and y squared terms have different signs, so therefore this would be a hyperbola. Group your x's and y's together. You have -16x squared. Actually, well, it doesn't matter. I'll go ahead and do it like this, and I'll show you how you could have done it different. Group your x stuff together, group your y stuff together, and move everything else to the other side. We're going to factor any number in front of x squared and y squared out. So our -16 in front of x squared factored out. You're left with an x squared plus x inside parentheses. Factor out the +9. You're left with a y squared minus 2y inside parentheses. And that should have been a 64 right here. So that would be a plus 4x. I made a mistake there. That was going to be really difficult to complete that square. So now, inside parentheses, let's complete this square. Half and multiply it by itself would be a plus 4, but be careful, because since you have a number outside of parentheses, you have to multiply those together to see what did I add to that side. Negative 16 times 4 is a negative 64. That's what gets added to the other side. Same way here. Half multiplied by itself gives you a positive 1. 9 times 1, multiply these together, gives you a 9. That's what you add to the other side. So now let's factor. X times itself gives you the x squared. What adds, multiplies will be half of this term, which will be a plus 2. Plus 9 times, let's factor this stuff. Y times itself gives you the y squared. Adds, multiplies will be a negative 1. Equals, let's combine all of this stuff. Gives you 144. Now the last step, here's what I was going to show you a while ago. Since this is the negative stuff here, notice that when you're dealing with a hyperbola, it's the negatives in the middle. So therefore, these two terms should be flip-flop. So I'm going to put my y term first because you got the positive stuff and then you've got the negative stuff to make it look like a hyperbola. And the last step is I've got to take and I've got to make this a 1. So we're going to divide everything by the 144, and that's going to give me my 1 on that side. So now we can reduce. 9 divided by 144 reduces to a 1 and a 16. So I have now y minus 1 squared over 16 minus the 16 and 144 reduces to a 1 and a 9. So that's going to be an x plus 2 squared over 9 equals 1. And there's your hyperbola. The center of your hyperbola can be found here and here. We're going to move it, be careful with the x's, we're going to move it left 2, we're going to move it up 1. So left 2 and up 1, our center is going to be located at negative 2, positive 1. From there, our a and b values. Our a value with a hyperbola is always listed first. This is a squared, so our a value would be 4. This would be our b squared value, so our b value would be 3. Since the y stuff is listed first, that's going to mean that this is going to be a vertical hyperbola. So to find our vertices, we're going to go up 4. 1, 2, 3, 4. We're going to go down 4. 1, 2, 3, 4. So that's going to be our vertices, and our hyperbola is going to go this direction. To find our co-vertices, we're going to go right 3, and we're going to go left 1, 2, 3, and that's going to give us our box. And a reminder that once you have your box, we're going to simply connect the corners of our box, and that's going to give us our asymptote lines that we're going to use to actually graph our hyperbola. And there are those asymptote lines. So from here on out, it's just where do I draw my hyperbola? Again, reminder, since the y stuff is listed first, it's going to be a vertical hyperbola, which means you're going to come up here and draw the first part, and then you're going to come down here and draw the second part. So there's your hyperbola. And again, the red part is the only part of the hyperbola. The rest of it was just lines that we used to graph it. Okay, the next one. Notice that your x squared and y squared, that the numbers are different, so this is going to be an ellipse. So let's group our x stuff. X squared plus 2x, skip a space, 9y squared plus 90y. Move the 190 over. And we do have to factor that 9 out before we can go any further. The x stuff, no problem. Go ahead and leave your space, but let's factor out that 9. Anytime there's a number in front of y squared, it does have to be factored out, or x squared. So you have plus 10y is equal to negative 190. Now let's complete our squares. Half it, multiply it by itself, gives you a 1. Since there's no parentheses around that, that's exactly what we add to the other side. Half this, multiply it times itself, gives you 25. However, to this side, we're going to multiply 9 times 25. We're going to add that to the other side. So we're now going to factor. X times itself, adds, multiplies, will be always half of this, will be plus 1. The 9, 2 sets of parentheses, or parentheses squared actually, adds, multiplies is always half of this, would be plus 5. Equals negative 190 plus 1 plus 225 gives me a 36. Next step, we're going to take and divide every term by that 36. First term, nothing simplifies, so I have x plus 1 squared over 36. plus the 9 and 36 reduces to a 1 and a 4, so that gives me a y plus 5 squared over 4 is equal to 1. So therefore, there is our ellipse. The center is here, got moved left 1 and down 5, so left 1, down 1, 2, 3, 4, 5. There's the center of the ellipse. And from there, we're going to take our a value and b value. So here our a squared is 36, so a would be 6. B squared is 4, so b would be 2. Since the since the 6 or the 36 is under the x, that tells us, again, x is horizontal. That tells us how far right and left to go. So we're going to go right 1, 2, 3, 4, 5, 6. We're going to go left 1, 2, 3, 4, 5, 6. Our b value tells you how far up and down. So we're going to go up 2, and we're going to go down 2. And that's our vertices here and our co-vertices here of our ellipse. So now it's just connecting the dots, and then you have your ellipse. And there you go.